There's a just I'll explain question. It'll be much easier. Very lengthy explanation is there. There's a rod. There's a rod. About this rod open, the disc and the charger ring can rotate, and also there's a non-conducting disc can rotate. So I'll take a rope or a string. I'll wound on it. Then I'll suspend a block of mass m. Then there's a charge ring. Charge is present. Let lambda be the linear charge density. Charge is present here. Let m1 be the mass, a be the radius, m2 be the mass of disk, and b. This is a neutral. There's no charge. So here I'll switch on a uniform magnetic field B naught T, which will be directed perpendicular to plane of the ring and also parallel to the axis. Then for equilibrium, what should be the value of m? How things are related here. So now let's variable magnetic field links. It will produce induced electric field. No? The induced electric field acting on the ring, will it set up any torque? Yes, that torque will be set up above this rod, and that torque should be balanced by torque due to the weight setup that is acting on the disk here. That's the overall the question. So now take away this induced electric field. Application is what we have to go for it. So I think diagram I can show. Yeah, see once. A non-conducting charge ring of linear charge density lambda, mass m1 and radius a, and a neutral non-conducting disk of mass m2 and radius b are free to rotate about a horizontal rigid rod passing through their centers as shown. Uniform magnetic field B equal B naught T directed perpendicular plane of ring is switched on. Find the value of mass m of the suspended block for equilibrium. Directly come for the ring. Take help of only the ring. So what are the forces that will be acting on the ring? So you convert this into some plane diagram. This is a ring. So where charge is present? Charge is present on the circumference only. And the radius of this is a, and there's a uniform magnetic field which is varying with the time. Will it set up any torque? Induced electric field in what direction will be? B bar into the plane. I'll magnify it. B bar is into the plane. What direction the induced electric field here will be? Will be tangential. And what is the value of E? E into 2 pi r or 2 pi a equal to pi a square dB by dt. So this should be a b naught by 2. Now you assume a small element. Assume a small element. The small element will have a charge dq. It will experience a force df. So what is that force? df equal to E into dq. So this should be equal to a b naught by 2 into dq. Will it set up any torque about the center O1? There will be a torque acting by this force. So df is equal to into a. So a b naught 2 dq into a square b naught by 2 dq. So let's go for the total torque acting on it. What is the total charge on it? Q. So a square b naught by 2, total charge is q. So we have lambda. Lambda is what? Q by 2 pi a. Linear charge density of this is given lambda. So a square b naught by 2, q will be lambda 2 pi a. Substituting all this, 2 will get cancelled. So pi lambda b naught a cube is what the resultant torque acting on the ring. In what direction? What is the sense of this torque? Will be like this. Is it okay? Torque due to induced electric field. Okay, fine now. So any questions will come now. Many questions are there. Please do like a ring kept on a rough surface, then time varying magnetic field B equal to B naught T square switched on. Find the time after which the ring starts rotating. How to calculate the torque? This one. The B naught will be as a function of time. 2 B naught T will come here. Then if it can overcome the torque due to friction mu mgr, it starts rotating. You do have problem in most of the books. Do work out. Very popular. Many teachers will try to hard that one. Even in advance, they may ask you because something with friction, they're trying to ask that one. So the same concept, if there's a ring, let me cover that idea here also. So there's a B bar, B naught T square, and there's a ring like this where charge is present on the circumference, kept on rough surface. Then torque due to this, how much it will come? 2 B naught T, dB by dt should be 2 B naught T. So torque due to induced electric field should be 2 B naught T pi lambda AQ. When it will start rotating? When it overcomes torque due to friction. What is the torque due to friction? Mu mgr. After this time only, the ring starts rotating. Non-conducting. How to calculate torque due to friction? You are already aware in the rotation mechanism. Directly I'm writing mu mgr. And let's come to the problem. So how do this torque due to ring will act in this sense? The torque due to this weight suspended, weight mg will act here. String will be taut. So this will set up a torque in this direction. So for equilibrium, what you should write? Torque due to ring should be torque due to weight. Simple application. Only thing is you must have that basic idea of induced electric field. This should be equal to mg into b. Pi lambda b naught aq by gb. This should be the answer. This is another thing, something related to the other concept. Ring placed on rough surface. After what time it start rotating? For t less than this value mu mg bar by 2 b naught pi lambda a cube, the ring will be attached. After this time, the ring starts rotating because the torque due to induced electric should overcome the friction. You do have all application. Now, straight away, application problems of induced electric field. Due to induced electric field, there will be torque. That torque you are going to link with rotation mechanics problems. Now, suppose if the mass of the suspended block greater than this, so what happened to system? It will start rotating. The net torque will be non-zero. I can introduce other ideas now here. Instead of string, I'll suspend a spring, then spring force and the weight will come into picture. Just multiple ways you try to analyze. Okay, I'll say goodbye to induced electric field. Rest all problems you should manage. Almost maximum ideas I shared with you. Any other logical question you'll bring it because there's an unlimited topic similar to Ampere's circuit law. So in exams, you be careful. Okay, let's take the different types of